Hello, welcome to another video with me, Mac at Phuket Pals. So today I'm going to talk about the IGCSE Chemistry Chapter 1, the particulate nature of the matter. Okay, so in this chapter we're going to talk about the property of the solid, liquid, and gases. And then we're going to talk about the kinetic theory of the matter, so to explain the states of the matter. Okay, and then we're going to talk about the changes of state and how can we change the states of the matter, and we will see the unusual states of the matter and unusual change of the state, and we're going to talk about the heating and the cooling curves, and then we're going to talk about the diffusion, the evidence for the moving particles, which called the Brownian motion. And then we're going to do the summary, the checklist, that things you need to know in this chapter. And we're going to talk about the additional question, which I brought from the IGCSE past paper, both of the writing sections and multiple choices. All right, let's start with the first slide. The matter. What's the matter? The matter is any substance that has mass and takes place of space by having the volume. Basically, it will have mass and volume. Okay? M and V. And what about non-matter? The non-matter, for example, such as the photons or the other energy phenomena, or like the waves such as the light or sound. Okay, so let's have a look here at this figure. The water has mass and volume. The quartz has mass and volume. The nitrogen dioxide has mass and in the container, which has the volume. So the water, quartz, and nitrogen dioxide are the matter. Okay, which here at the bottom right, the plasma. The plasma is the light. Okay, it's another kind of the other kind of the energy, which doesn't have the volume. Okay, so the plasma is non-matter. Okay, let's see the first states, the states of the matter. The first one is solid. Okay, what's the solid? We're going to talk about the arrangement of the solid in this figure, the model of a chrome alum crystal. This is an actual chrome alum crystals here. The arrangement of the solid, it's in the regular repeating pattern. Is in regular and repeating pattern, and it's close together. Yeah, each particle, each ball represents one particle, are close together. Okay, and it's touching each other. And the movement, they vibrate about fixed position, but do not move apart. It can be vibrating at a fixed position, but it couldn't move apart, okay, each other. And the forces between the particles, are stronger than in the liquid. Okay, because the particles stay closing together and it's touching each other. Okay, so that's why the forces between particles that leading to get more stronger. Okay, and the shape and the volume are in the fixed shape and volume. All right, let's have a look here. The train track. So can you see here? This is the gap. The gap they're using for we call here the expansion gap. Okay, expansion gap. At a given temperature, has a definite volume and shape, which may be affected by changes in temperature. The solid usually increases slightly in size when it's heated, so which means it will get expand. Okay, and usually decrease the size if cool. It's contraction. So that's why on the train track, we will spare the gap for the expansion and the contraction for the changing of the weather. For example, in summer or in winter. Okay, so in summer, the trend track will slightly increase the size because of getting the heat, right? Because of receiving the heat, so leading the material or the track getting expansion. And when it turns into autumn or turns into the winter, which is the temperature is cool, it's cooling down, and it's decreased the size of the material. So it's caused the contraction. Okay? The particle in liquid. The particle in liquid, the arrangement of the particle is irregular. Okay? But it's close together and touching each other as well. And the movement of the liquid, they move around and slide apart to one another. And the forces between the particle is not strong as the solid. And the shape, no fixed shape, okay, doesn't have the fixed shape, but the shape will change by the container, okay. The container will change the shape, but the volume is fixed, okay. So for the shape of the liquid, it has fixed volume, but shape can be changed. Can be varied by the container. Okay. Another kind of the matter, the particle in gas. Let's have a look here, the particle in gas. There's slightly particle in the box, right? There's slightly particle in the box. The arrangement is irregular and it's far apart. Okay, it's far apart and it's irregular. The movement, the gas particle are moving freely and collide with each other. Okay, it moves freely in the box, in the container, and it's collide each other. The forces between the particles doesn't have the force between particle because it stay far apart from each particle. Okay, so and the shape and the volume, it doesn't have the fixed shape and it doesn't have fixed volume. The shape can be changed by the container, and the volume can be the gas can be occupy the container up to the volume of the container. So that's mean the gas particle doesn't have the fixed shape and doesn't have the fixed volume. Okay? All right. So let's have a look here, the kinetic theory of the matter. The kinetic theory, it helps us for explaining the way in which matter behaves. Okay? The evidence is too consistent with the idea that all matter is made up of the tiny particle. This theory, the kinetic theory, will explain the physical property of the matter in the terms of the movement of its constituent particles. Okay? The kinetic, it will explain the movement. It will explain the movement because kinetic means the movement. Okay? So let's have a look here, the solid. The particles only vibrate about the fixed position and regular structure. Okay, for solid. The kinetic theory for the liquid. The particle have some freedom and it can move around each other. It's collide often. Okay, and for the gas here, can you see the particle of the gas? 3 particles here. The particles move freely and at the random in all the space available, and it's collide less often than the liquid because each particle has the far apart of each other. Okay, this is the kinetic theory of the matter. All right, let's talk about the changes of the state. So aforementioned in the solid matter, let's have a look here, the trend track. Okay, which can you see the distortion? The distortion of the trend track because of the heated, right? If a solid is heated, the particle vibrate faster, okay? Heated, it vibrate faster because they gain the energy, okay? The solid heated particle vibrate faster because they gain the energy, which means it will make them push their neighboring particle, okay? Push the neighboring particle further away from themselves. It will cause them increase in the volume of the solid, and then the solid will expand. Then the expansion is taking place, okay? When the solid, this is the solid particle, it's getting heat, right? Receives the heat, and it start vibrate each other and push them away like this. Then it causes the expansion, okay? Then you can see the distortion of the train track when it's in summer, okay? The heat energy, it will cause the forces of attraction to weaken, okay? The irregular pattern of the structure, it will break down because of the heat energy, okay? And then the particle can now move around each other. So then the solid has melted, okay? So at the temperature which it takes place, we call them melting point of the substance, okay? So the temperature of a pure melting solid will not rise until it has all melted. So which means the temperature will increase, right? We increase the temperature, then it reaching the temperature that the solid has melted. Then it will keep constant. It will keep constantly until the pure melting solid has all melted. Then the temperature will increase to another temperature, to the higher temperature. Okay. The solid here, the melting point, right? Okay, MP. Here it will stay, will keep constantly the same until pure solid all melted. Okay, then it start rising again. Okay. So for deeper detail, okay, for more details, I'm gonna talk in I'm gonna explain in the changes of states, the curve, the temperature curve. Okay. All right. The solid which have higher melting point, it have the stronger force. The high melting point will have stronger force of attraction, okay, between the particles than those which have the low melting point. Let's have a look here. The melting point of the aluminum, ethanol, magnesium oxide, mercury, methane, oxygen, sodium chloride, sulfur, and water. So let's have a look here. The melting point of sodium chloride is 801 degrees Celsius comparing to the magnesium oxides here. The magnesium oxide has the melting point 827 degrees Celsius. So the magnesium oxide has higher melting point, so which means the attraction force of magnesium oxide is stronger than the attraction force of the sodium chloride. Okay. All right. Let's talk about evaporation. Evaporation, if the liquid is heated, the particles will move around even faster. Okay, if the liquid is heated, the particles will move around even faster. It's going to move faster because the energy is increasing. Okay, some particles at the surface of the liquid have enough energy to overcome the force of attraction between themselves and other particles in the liquid. So they escape from the gas. The particle here. Let's have a look at this particle. Because it has enough energy. O-E-N-O-U-G, energy. Right? To overcome the attraction. The attraction force. Okay? This is the particle at the surface. Okay? The surface, that means is at the top here, around here, this region. Okay, because it's gaining the heat energy and increasing the energy. Then it reaching the enough energy, right? It's reached enough energy to overcome the attraction force. Then it will escape from liquid to gas. This phenomenon we call the evaporation. Okay? Evaporation means the particle at the surface getting heat and reaching enough energy to overcome the attraction force, and then it will escape from liquid to gas. All right? So, and what's the difference between evaporation and a boiling point? A boiling point is the temperature is reached at which particles are trying to escape from this liquid. Okay, so quickly that the bubble of gas actually start to form inside the bulk of the liquid. Okay, so the difference between evaporation and the boiling. The vapor pressure is less than the atmospheric pressure. Okay, the VP is less than the AP. Okay. Actually, I'm gonna write here the PV. Okay, PV, the vapor pressure, is less than the PA, less than the atmospheric pressure. And for the boiling, so if the PV less than PA, the bubble cannot form, which is the evaporation. But at the boiling, the vapor pressure, the PV, equals to the PA, the atmospheric pressure. So we can see the bubbles, okay? The bubble can form and rise. Okay? This is the boiling. This is the differences between evaporations and the boiling. All right. Another phenomenon of the changes of the state, the condensation. The condensation, when the gas is cooled, the average energy of the particle decreases. Okay. And the particles moves closer together. So the force of attraction between the particle now becomes significant and cause the gas to condense into the liquid. Okay? Basically the condensation, that means the gas is cooling down. Okay? The energy of the particle decreased, then it moves closer together. Okay? And it's caused the gas condense to the liquid. Okay, the condensation from the gas to the liquid. All right. This is the concentration. This is the condensation. Excuse me. Another changes of the states, the freezing. Okay, the freezing is happened when the liquid is cooled. It freezes to form a solid. Okay, in each of these changes, the energy is given out. So basically, the freezing is the changing of the liquid into solid. All right, so we can just do a bit summary here. The solid, liquid, and gas. So the changes of the states from solid to liquid we call melting, right? LT, melting. And changing from liquid into gas, evaporation. And changing from gas to liquid we call condensation. And the changing of the liquid into solid we call freezing. So here the temperature increased, right? But here the temperature was decreased. Okay. All right. The unusual state of matter. Have you ever heard of the LCD screen? The LCD screen that stands for the liquid crystal display. Okay. What is the liquid crystals? The liquid is the liquid, and the crystal is seemingly to be the solid, right? The crystal, this meaning it's kind of the solid. The liquid crystals are an unusual state of the matter. Okay, so see this figure. This figure 1.7, a polarized light ion micrograph of the liquid crystal. The substances look like the liquids and flow like the liquids, but have some order in the arrangement of the particles. Okay. Because of the arrangements of the particle, it behaves like the crystals. This is why we call them liquid crystals. Okay? This the LCD, the liquid crystal. Then we can see the change of the color, like we can see the many colors on the screen. This is how we use in our daily life. The liquid crystal are used in the TV screens. Okay? Another thing is the sublimation. The sublimation, there are few substances that change directly. It changed directly from a solid to the gas. Okay, and then the cooling it causes a change from a gas directly back to the solid. Have you ever heard? Have you ever seen it here? The smoke here on the stage. This is the example of the dry ice. The dry ice is the carbon dioxide. Okay, the solid carbon dioxide. When the carbon dioxide is a white solid, we call it dry ice at the temperature below the minus 78 degrees Celsius. So when it's heated to just above minus 78 degrees Celsius, it changes into carbon dioxide gas. So that's why we can see smoke here. All right. Another kind of the substances as well, the matter is an iodine. Okay. They sublime from solid to gas and sublime from gas to solid when it's cooling down. All right. This is the summary, okay? The kinetic theory will explain the movement of the particle when it's received when it's getting the heat, right? The particles start vibrating and pushing the neighbor particle away. Okay, then it loses the attraction force. Then it starts melt and turn into liquid, and then still continuously receives the heat, right? And then it reach the temperature that change the particle to have enough energy to escape the liquid into the gas. Okay, this is evaporations, right? And if boiling, that's mean the vapor pressure equals to the atmospheric pressure. Then it's turned to gas. And then when it's cooling down, the gas condenses, right, loses the heat energy. Then the particles close each other, then it changes to liquid. And then after that, we cool down. Then we will see the particles of the liquid are moved closer and arrange the particle orderly. So now it's turned into solid. Okay? And it changes states directly from solid into gas we call sublime. All right, for example, the carbon dioxide, the dry ice, and the iodine. Okay? All right, let's have a look here. The heating and the cooling curves. Okay, remember that I've already explained, just a little bit explained the introductions of the changing state of the melting point, right? So at a given temperature increasing for the solid. This is a solid anites, okay, starting at -15 Celsius. And it's reaching 0 degrees Celsius. Okay, here is the melting point. Okay, so the solid and liquid, which mean the ice will melt to the liquid, or the ice will change into water. Okay, so we will see here the ice and liquid water, and the melting point will keep constantly the same until all of the solid are melted. Then it starts increasing the temperature again. So in this region, all water particles are liquid water. Okay? Now it's increasing and it's reached this temperature at 100 degrees Celsius. Here we call the boiling point. Or BP. Okay? So at the boiling point at the BP, the liquid, it starts to change the states from the liquid into gas. So we'll see here the liquid water and the water vapor at this curve, okay, at this region, around that time. And it will keep constantly the same temperature until all of the liquid water change to the water vapor. Then it's going to start increasing again. Okay, this graph is shown. It was drawn by plotting the temperature of the water as it was heated steadily from -15 degrees Celsius to 110 Celsius. Okay, this is the heating and the cooling curves. All right. This is the apparatus that shows how can we make the heating and cooling curve. Okay, so if heated slowly, it can be used to find the melting point of the substance at such as the solid in the melting point tube. So we can heat, okay, heat the solution or heat the solid. This is the solid, this is the oil, right? We put the solid into the melting point tube, and this is the oil to receive the heat energy, and this is the thermometer to measure temperature. This is the time, okay? This is the temperature. Okay. We can design the table like this. okay, with the time interval and the temperature, okay. And here we can see the note of the changing states, right? So then we can set the time interval here, or collect the time like 1 minute each, blah 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 blah. Then we see the temperature, and then we will see the change. It's gonna be like this and like this. Okay, this is how can we drawing the heating and the cooling curve. Okay, we're gonna talk about another phenomenon of the matter, the diffusion. The diffusion is the spreading out of the gas. Okay, we call the diffusion. And the diffusion will take place in the haphazard and in random way. Okay, let's have a look here, the gas jar, this figure. All gases diffuse to fill the space available. Okay, it will diffuse to fill the space available. In this figure, after the day, the brown red fume of the gaseous bromine. The gaseous bromine, it spreads around throughout the gas jar. Okay? This is the diffusion. And the diffusion, it also takes place in the liquid. Let's have a look at the beaker A and the beaker B. Okay? But a liquid will have much slower process, okay, than the gas, because the particles of the liquid move much more slowly than the gas, okay? Let's have a look here, the experiment. The experiment between the hydrochloric acid, right? The concentrate hydrochloric acid and the ammonia solution, right? The concentrated ammonia solution. So we can see here the white cloud, right? The white cloud precipitation in the tube. Let's see here. The gases will diffuse at different rates, okay? The rate is the speed, right? In respect of the time. The distance and the time, okay? We call the rate. The rate of diffusion. Okay, if one piece of the cotton wool here, it's soaked in concentrated ammonia solution. Okay, this is an A and this is an B. And another soaked in the concentrated hydrochloric acid, and these are put at opposite ends of the dry glass tube. Okay, and then after a few minutes, a white cloud of ammonium chloride. The ammonium chloride appears. Okay, so it's appeared. It shows here the position that two gases meet and react. Okay, so the white cloud, it forms in the position. It shows because it shows here. It shows it's close to hydrochloric acid because what? Because ammonia. Comparing ammonia and hydrochloric acid, the molecular mass. The ammonia solution, the ammonia molecule, you just have 14 plus 3, right? 17, around 17. While the hydrochloric acid has 35.5 plus 1. 35.5 is AR for the chlorine, and 1 is for the proton. 36.5 approx. which means the ammonia it's much lighter. Okay, it's lighter than the hydrochloric acid. So the lighter will move faster, right? The smaller mass will move faster. Okay, that's why the white cloud precipitate of the ammonium chloride is present in the region like close to the hydrochloric acid. Okay, this is the example for the gases diffuses in the different rates. It depends on, it's up to the molecular mass, or the MW, the molecular weight. Okay, the greater MW will go slower and smaller MW will go faster. Okay, all right. The Brownian motion. The Robert Brown, he observed the fine pollen grains on the surface of water were not stationary. It's moving. Why is it moving? Through his microscope, and he noticed that the grains were moving about a random way. Why? Why is it moving? And another scientist, we call him Norbert Wiener, he explained what Brown has observed. He said that the pollen grains were moving because the much smaller and faster moving water particles were constantly colliding with them. Because in water, there are smaller particles will constantly collide with the pollen grain. That's why the pollen grain is still moving. Okay, so this random motion of the visible particle, the pollen grains, is caused by the much smaller invisible ones. That is water particles. So we call them Brownian motion. Okay. The visible particle caused by the motion of visible particle caused by the much smaller invisible one. Okay, we call the Brownian motion. This is the Brownian motion. Okay. Here we are in summary. The things below here you need to know. Okay, you need to checklist the chapter 1. You should know and understand the following terms. The first one is the atmospheric pressure, the boiling point, condensation, the diffusion, evaporation. The evaporation is the process that occurring the surface of the liquid involving the change of state of the liquid into vapor. The kinetic theory is used to explain the property of the matter in terms of the constituent particles, like the moving particles. Okay. The matter is anything which occupies a space which has a mass, or basically the matter is supposedly to have mass and volume. Okay, the melting point is the temperature at which the solid begins to change the state to the liquid, or begins to liquefy. Okay, so a pure substance will have a sharp melting point. The solid, liquids, and gases, there are 3 states of the matter, okay, which all substances belong. Another one is the sublimation. The sublimation is the direct change of states from the liquid into gas, okay, and then it reverses the process again. All right, this is the end of the chapter 1. Now we're gonna go for the question. I just finished explaining this this experiment before, the rate of diffusion. Okay, let's do it again. The concentrated ammonia solution, it gives out the ammonia gas. Okay. Concentrated hydrochloric acid gives off the hydrogen chloride gas, and the ammonia and hydrogen chloride, the HCl, are both colorless gases. Okay. The ammonia reacts with hydrogen chloride to make the white sodium ammonium chloride. White solid ammonium chloride, sorry. So the apparatus is set up as shown. The glass tube, the stopcock, the cotton wool, it's soaked in the concentration ammonia solution. Okay, and here at this region, it has hydrochloric acid, right? Which are concentrated. After 10 minutes, a white solid forms in the tube where the gases meet. Question A. A1. Write the chemical equation for the reaction of ammonia with hydrogen chloride. The ammonia gas react with hydrogen chloride gas. It will give out the white precipitation, right? The white cloud, right? It's the white cloud of the ammonium chloride. Is the chemical balances 1 atom of nitrogen, 1 atom, 4 atoms of hydrogen, here 3 plus 1 or 4, and 1 atom of chlorine. Here 1 atom of chloride. So that means this chemical equation are balanced. And number 2, name the process by which the ammonia and hydrogen chloride gases move in the tube. What we call is the diffusion, right? The gas will occupy the container when the time passes by. This is the diffusion. At which point A, B, C, or D does the white solid form? Explain why the white solid form at the point. So aforementioned, I was talking about comparing the molecular weight, right? The MW of the HCl and the MW of the ammonium chloride, of the ammonia gas, right? So which means the NH3 here will move faster, and here it will move slower. Okay, at 10 minutes, we can see the white cloud here around here. Okay, the white cloud here is the ammonium chloride. So which means we can see the white solid form at point A. Because the ammonia molecule have smaller mass, right? Then it will diffuse faster. Get 3 points. Okay? Because the ammonia molecule has a smaller mass. The smaller mass will diffuse faster. Okay? The smaller mass will diffuse faster. Alright. And number 4. The experiment was repeated at the higher temperature. Predict how the result of the experiment would be different. Explain your answer. Increasing temperature. Increasing temperature will increase the rate of the reaction because the particle will move faster. So that means the result, we can see the solid, the white solid form faster, right? Because the BECAUSE, the particle have, where's my pen? Okay, here. Have more energy. right? And so it will move faster. Okay? 3 score. Next question, the multiple choices. In which changes do the particle move further apart? Let's have a look here. This is the gas, the liquid, and the solid. It's moved further apart because it's getting heated. So which means it increases the temperature. Which direction? From solid to liquid, right? The temperature increases, and from liquid to gas, the temperature increases. So that's mean the change in Z and the change in Y are make the particle moves further apart. So the correct answer is D, Y, and C. Okay? So the diagram X, Y, and Z represent the three states of the matter. The X is the solid, right? Y is the liquid, and Z is the gas. Okay. Which change occurs during the boiling? The question is, which change occurs during the boiling? The boiling is changing from Y to Z, or from liquid to gas, right? So then the correct answer is going to be A, from X to Y, solid to liquid. No, the solid to liquid is melting, right? Here's melting. Y to C, evaporation, right? Or boiling, right? And C to X, sublime. And Z to Y is condensation. So the correct answer is going to be B, Y to C. Alright, number 3. Which change of state takes place during the evaporation? This question is real analog to the question 2. There's difference in the picture, the diagram, and the sentences. So, during evaporation is the changing from liquid into gas, right? Which one? Which choice? The choice B, right? B is the correct answer. Number 4. In which process do particles move closer together but remains in motion? It moves closer together but remain in motion. So that's mean it's slowed down, right? It's cooling down the temperature. Then the particle moves closer, but it remains in motion. So which means it's gonna change from the gas to the liquid. Changing from the gas to liquid, this phenomenon we call the condensation. So the correct answer is gonna be A, condensation. All right, and last one, number 5, but not least as well. The changes that occur when the substance changes states are shown below. The solid, what is the W? The W is melting, right? The liquid to gas here is evaporating. And from gas to liquid are condensation. And the liquid to solid is freezing. Okay, let's have a look here. Which process W, X, Y, or Z is occurring in the following 4 situations? 1. Butter melts on a warm day. The butter is a solid, right? It melts on the warm day. So that means it's changing from solid to liquid. It's letter W. Okay, the water condenses on a cold surface. Water condenses on the cold surface, which means it's changed from the water vapor or the water gas to the liquid, which is the Y, right? And the volume of liquid ethanol in an open beaker reduces. The volume reduces, which means it's changed from liquid into gas, right? Which is an X. And the ice forms inside a freezer. So which means it's changed from the liquid to solid, right? Which is Z. So 1 is W, 2 is Y, right? 3 is X, and 4 is Z. So the correct answer is gonna be B. Okay? So I think this is the example of the question in both the paper 1, paper 2, and paper 4, paper 3 and paper 4 as well, in the writing part. So I think that's gonna be it for this chapter 1. If you have another question, or if you want me to explain more information about the chapter 1 or another topic about the IGCSE chemistry, you can just drop the comments below here, or you can just go to our Facebook, Phuket Pals, or our YouTube, Phuket Pals, or you can email directly to info@phuketpals.org. So I'm going to be happy to do that. I'm happy to respond to you as soon as possible. All right. Thank you and have a good day. Bye-bye.